Yeah, about the test, I found out some students did not scan all the pages. I don't know. That's why I sent the email to a number of students. I just couldn't find the solutions to problem 2 or 3. I don't know whether it's on purposely left over, or maybe forgot to scan that page. Yeah. So for the test, see, this is maybe I did not say anything, but this is an open book test. You have freedom to look at any formulas, look at the lecture notes, examples, right? But you cannot just, cannot do as a cheating, but you can have access to the books, lecture notes, and the homework problems. Okay. Same is true for the final exam too. Oh, well, you can ask me. Anyone who wants a test back with my grading, you can email to me. I can send you by attachment of the email. Okay. Yeah. There's some mistakes. For example, like problem number 9. This parabola is open downward, right? And you want to find the centroid of the region between the parabola and the x-axis. But when you draw the graph, also you draw the y-axis. Then with some of you think the region is in the first quadrant. But actually, this is a region first quadrant and the second quadrant. The y-axis is you just draw that. It's actually not that. It's the region between the two curves. One is the x-axis, the other one is the parabola. So obviously, the x bar, the x coordinate of centroid is 0 because by the symmetry, you don't need to waste time to even do the computation. I just give an example. Some students lose a point because they did not pay attention to the problem. Maybe sketch the graph and mistook the region. Today we'll continue to talk about parametric equations and how to use that to solve other problems, like even the length of the curves and the area of the surface of the ocean, for example. Okay, so you look at the curve in the xy plane, right? And suppose it's parameterized by 2 equations, okay? And you want to find out the tangent line at that point. So the slope, this is a point x naught, y naught, okay? So they are given by okay. So question is, how do we find the slope? The slope, right? And if we view it as a graph of some function, then that'll be dy dx, right? However, in some cases, we cannot find the function. We cannot find the formula for the dependency of y on x. So how do you do that? You change it by the chain rule. This is a dy of dt, dx of dt, okay? And then you switch to So in other words, it's a y prime, not x prime. So this is another formula you can use to find the tangent slope of the tangent line. Then you can find the tangent line, right? So here's the example. The curve is described as these two parametric equations. Okay. If you want, yeah. So here's the point. So find the tangent line at the point 3 and 0. Because this is a point in xy plane. So you have to figure it out. Yeah, you have to figure out the point, right? Where it is. Okay. So first of all, yeah, this is x now, right? Right now. So you need to find the value. Okay. So which equation you prefer, doesn't matter which one. So it's going to be 3, that's going to be 0. Okay. And you will see that the second equation here is t naught, right? So as long as the first equation holds, then the second holds. So all I need is just solve this equation. Okay. So that implies you have two solutions. Okay, that means the graph has a self-intersection point. Okay, it looks like that, going that way and this way. So here when t equals negative square root 3, then that's also when t equals positive square root 3, it's coming back. Okay, so if you want to find a slope, there's two different slopes here. Okay, be careful. So the two tangent lines to the curve. Okay. So the slope is going to be right, and then let's differentiate. So it'll be 3 t naught square minus 3. Okay, that's 2, right? Where you differentiate in y and x. So the first slope is when t naught is going to be negative 3. So that's going. This is a 3, right? Always, right? And the minus 3 divided by 2 times square of negative 3. So it's going to be here the 6. So the answer here is square root 3, negative square root 3. Okay, after simplifying. Okay, the second one, the denominator is positive square root. So after simplifying, just positive square root. So you have two slopes because you have two tangent lines. Okay, the first one is y minus m1. Y minus, I think the second component 0, right? Y is minus x minus 3, okay? Which is negative 3, x minus 3. The other one is y equals m2. Okay, so there are two tangent lines there. That is how do we find, how do we find tangent line? Now, if, so if x depends on t, y depends on t. But we still want to find out how to find out the value, right? dy dx, right? When x equals 1, right? So at a particular point, okay, I just showed to you, this is going to be y prime t naught and x prime t naught, right? Okay. But the question, how can I find the second derivative? Yeah. With respect to t. So x depends on t, y depends on t. So in some cases, y depends on x. Okay. If y depends on x, so you can find the rate of change in y with respect to x. Since you cannot express y as a function of x directly, explicitly, so you still have to use the function x of t, y of t to find the second derivative. Okay. To do that, yeah, let's derive some formula. So this is a d of dx, right? And then we already know what is that. Okay. So this is a function for x. Okay. So I can express it okay. This is as a new quantity. Okay. Right. Right. So it's a function of x, but this is also a function of t. So you can divide by, you can view this like this. So then the numerator and denominator both are divided by t, then you get this, right? Now we already have this. This is dy dt of a dx dt. Okay, then you use the quotient rule for the numerator. So you get, let's just use x prime, okay? X prime t squared, and this is a y prime, and you double it, right? Minus y prime t and x double prime t. And here x prime t is no square, just x prime t. Okay, so after you simplify, you get this. So this is a formula one can use to find the second derivative. Okay. Okay, you can. Here's the question. Okay, so use the same function. Okay, we still use the same function, but I'm trying to use that at a different point. Okay, so here's the point. Okay, x equals right t squared, y equals tq minus 3t. Okay. 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 Find the dy dx when x equals 1 and the second derivative. Okay. Now we assume that y depends on x, but it's complicated, right? So we don't want to express y in terms of x and differentiate. What we do is dy dx, right, and the dy dt and dx dt. So you do get a formula here, 3t squared minus 3, and here's 2t. Okay. Okay. So when x, how to get x equal 1? X equal 1, and actually there will be two possible solutions here. Let's take a look, right? When x equals 1, this implies t squared equals 1. That implies t equals plus minus 1. Then the corresponding y value just have a sign because this is a t squared minus 3, right? T squared is always equal 1. So it's negative 2 times plus minus 2. So it's a negative 2. Yeah, this is a plus minus 1, then times negative 2. So it's going to be minus plus 2. Okay. So you have a two different points of y corresponding to the value x equals 1. Now, what does that mean? That means when x equals 1, here, the y value is negative 2, a positive 2, right? 1 and a positive 2, and here 1 negative 2. So the graph maybe looks like that, okay? Who knows, okay? So either you take this piece or take that piece to find the derivative, okay? So there are two possible solutions, okay, right? When x equals 1, okay, the first solution is when t equals positive 1. So that's 3 minus 3, 2 times positive 1, and it's going to be 0, okay? Okay, so it doesn't matter which piece you choose because it's horizontal either, okay? Because t squared is 1. So now the second derivative, okay, is going to be differentiate this. So dy over dx is going to be the derivative here, right? So let's use a prime, 3t squared minus 3 prime. And this will be just 2, x is, dx over dt is just 2t. Okay, okay, let's differentiate. 2, let's use it, just 2. And use a quotient rule. Okay, so use a quotient rule, keep it constant, okay, t squared, and then differentiate the numerator. That'll be 6t times t, okay, times 6t times t minus 3t squared minus 3 times 1 because the derivative is 1. So let's put it here. So 4t cubed, then 6t squared minus 3t squared minus 3 plus 3. Okay, so that's what we get. Then the second derivative when x equals 1 is and t is going to be plus minus 1 because we have two possible values. The numerator doesn't matter, it's just only 1, right? 3 plus 3. The denominator is a plus minus 1. So you have two solutions. One is 3 over 2, other one is negative 3 over 2. Okay, that's the second derivative. Okay, so when t equals 1, when t equals negative 1. Okay, because this there's two different points there. Okay, so that's how they find the second derivative function. Although we cannot express y in terms of x explicitly, but we can use the parameter t to find the derivative. Now now we're talking about the length of a curve. Okay, the length of a curve, I already discussed this before, right? So given a curve, the length is going to be integral ds, right? And then if x is equal xt, y is yt, then ds is going to be is going to be this one square, right? And times dt. So t is from alpha to the beta. Okay. So this is actually ds. Okay. But now you change the variable, I'll change it to an arbitrary variable. Okay. If t is also arc length, then the square root of these two squares is going to be 1. Okay. So this is a very useful formula. You can quickly find the length of the circle. Okay. If you do not use this formula to find the length of this, find the circumference, then it could be complicated, and you have to use substitution to evaluate. But there are some curves cannot be viewed as graph or function, and so then this is a formula you can use to find the length. Okay, so here we are given x equals r theta minus sine theta, y equals r 1 minus cosine theta, and theta is between 0 and 2 pi. Find the exact length. Yeah, find the exact length. Right, you don't need to draw the graph. Okay, yeah, the graph has some geometry meaning here. Yeah, this is actually an orbit in the space when you rotate a tire. Now, suppose it is a tire, right? And you mark the point on the tire. When the tire rotates, you keep a track on this point in the space. So after the tire complete the whole circle, okay, and then back to the ground, then this is the orbit of the tire, okay, of the point on the tire. Anyway, so we want to find the length, right? So using the formula, the length right on the formula is from 0 to 2 pi, and this is a dx, d theta square plus dy d theta square, and here d theta. Okay. Well, the derivative of x with respect to theta is r, right? So 1 minus cosine theta okay, plus yeah, it's r square here, r square, and the derivative of this will be sine theta. The derivative of y with respect to theta is sine theta. The question is how do we simplify it to evaluate this integral? Okay, you take a r out, right? So let's put r here. And the inside, this is 1 minus 2 cosine theta plus cosine square theta. This is sine square theta. So it's 1 sine square plus it's 2 minus cosine theta dc. Okay, are we able to get rid of the radical? Yeah, you think about it, okay? Right, to evaluate this integral, you have to get rid of the radical. Right, you have to get rid of radical. Now, we know that 1 minus cosine theta is going to be, right, it's going to be 2 sine square half of theta. Okay, so use that formula. When theta is between 0 and 2 pi, and half theta is between 0 and pi, that implies sine half theta will be greater than 0. Because when we remove the radical, we have to make sure the sine half of theta is positive. Otherwise, you have to put up a absolute value. So the length here is going to be square root of, right, 2 times 2 sine square half theta d theta. Okay, so I take a 2 out, it's 2r, and then this is just half sine theta d theta. That's all we need, right? So the antiderivative is going to be negative twice of cosine half theta. Okay, and then that's from 0 to pi. Okay, cosine pi is -1, and plus twice cosine 0 is positive. So actually here you get 2, and 2 times, well, you get 4. 4 times it's 8 pi. Yeah, you get 8. All right, so 8 times is the length. No pi here. Surprised. Yeah. Right. Right. Then for the same reason, you can set up a formula for the surface of for the area of surface of a revolution. So you have an axis, and then you have a curve here. Then you rotate this curve around that axis, so you get a surface of a revolution. How can I find the area, right? The area, remember, the area is going to be integral 2 pi r ds. What is ds? If this is the original curve, right? This will be the ds, right? And what is r? R. Now here's the point. Nobody, almost nobody, when you did the last problem on the test, nobody draw the picture, nobody marks the radius. I don't know why. How did you get this formula? How do you get the formula for that? This is required. It's part of the solution, actually. Okay. I have to insist on that. Right? If you draw the picture, then you know what is radius, why, right? Most of the students just give me the integral. That's it. No explanation, nothing. Okay. And if a part of the integral is wrong, should I give you partial credits or not? Right? Because I did not know how to get this. But the integral is wrong, right? You cannot say only small portions in the function here, because it's right? It's wrong, just like a machine, like a part of the parts is broken. The machine does not work, right? But if you show me how do you get this formula, that means you show me you have a certain knowledge about this. Then you deserve partial credits. So let me repeat again. You're here in the class. Okay, I hope you attend my lecture or watch the video. Let me again. For any area of the surface, you must draw the picture. You have to show me where's the radius, okay? And mark it clearly. That's, express radius in terms of x or y, if you want to use the x value or y value. Okay, can I just put the formula there? That's a high risk, you get no partial credits if the formula is wrong. Okay, because I don't know where you get it. How do you get it? Right? All right. Yeah, because this surface is approximated by kind of surface like that. Okay, then we know that if you have a surface especially like that, this side is ds and this radius is r, then the area is going to be, yeah, we call the area small as 2 pi r times ds. Okay, you can take the area of this surface. I add them together, you just use integral, you know. Okay. Then you get a total area. Okay. All right, so let's do the problem. Let's work on some problem. So we are given x equals sine t, y equals sine 2t. T is between 0 and the power 2. Now this notation is about the x-axis. Okay, I want to set up integral with respect to t for the area of the surface. Okay. So here's the x-axis, this is y-axis. When t equals 0, right? X should be 0, y should be 0. When t equals pi over 2, x is going to be 1, y is going to be 0. But for t between 0 and pi over 2, I think sine t is positive. Even sine 2t is positive. Sine 2t is between 0 and pi, so it's positive. That means it's a graph. Right? So this curve rotated about the axis. Okay. So how do we solve the problem? You take an arbitrary point here. That's what I want to see, but nobody, almost nobody. You can check your submit test. Did you draw the picture like that? And you mark the radius. You have to tell me what is that. What is radius? Radius in this case is F, is Y. Okay. It's not necessary, but I do need to know what is, ds is always, yeah. So ds, this is a dx squared plus dy squared, and depends if you want to take a dx out or you want to take a dy out, right? Depends on the problem. Okay. What I don't want to see is just give me the integral, okay, on the test. Because this is a college, it's not like a elementary school. You just give the answer, the teacher grade it. Maybe that's not, teacher will not grade it because they don't have time. They just scan, right? If the answer is wrong, 0 points. If the answer is correct, maybe 5 points or 10 points, depends on the problem. Okay. In the college, the problem is, most of the problems is a pretty big problem. So you involve so many steps, it's complicated. Nobody expects to get, I can always get 100% correct. Okay, so you don't expect me just give me credits based on the answer, right? You want me to look at solutions. So you're telling yourself, no solutions, how can teacher give you partial credits if you just give me the answer? So that's the difference between answer and the solution. Answer is just the integral or the number, right? Solution consists of answer, all the steps, and the picture, including the picture graphs. All right, so now, so the surface area is going to be from integral, right? 2 pi at the very beginning. This is just, you can simply write like this. Then you want to change the t variable. T is from 0 to pi over 2. 2 pi. Now, I is going to be equal to y, but y depends on, at that particular point, depends on time t. So that's why you have sine, you can put like a sine 2t, right? So it's very clear where sine 2t from, right? 2t. Then here's a derivative of x, right, with respect to t. So that will be cosine t squared, and that will be 2 cosine 2t squared and the dt, okay? Yeah, or you can simply write like this, and the dx dt squared plus dy dt squared and dt. That's the first step, right? And t is from 0 to pi over 2. Then you have to replace every term in terms of a t. So y cosine 2t. So that is yeah, this is, we set up an integral here. Okay. Now, if what happens if the rotation is about the y-axis, okay? In that case, you will get a graph like that, right? Yeah. How do you set up the integral? I don't want to see an integral here. I want you to know, take an arbitrary point, right? Okay. And x and y, and this is my radius. So radius is clearly going to be x. That's all we need. Okay. So the area is going to be integral 2 pi r ds. So that should be 2 pi I is x square. So if you want to use just dx dt square, dy dt square dt. Okay, t should be from 0 to pi over 2. Right. And then you look at what is x. X is sine t, right? And here it's going to be cosine t when you differentiate 2 cosine 2t squared. Then how about rotation? Rotation is about x equals 1. If we draw the picture, you know what is going to do. Unfortunately, some students lost 3 points. The question is, why I lost 3 points? I'm supposed to get 100%, right? Okay. Did you not draw the graph, right? This is the picture, right? And here's the 1, x equals 1, right? So rotation is about the x-axis, x equals 1. Okay? So on the original curve, you pick up an arbitrary point, x and y. Then you draw the line, and here's the radius. So r, you have to tell me what is r. Now, remember the last problem on the test. Some students knew that this should be the difference between these 2 points. But I put x minus 4 in when the vertical line is x equals 4. But x minus 4 is a negative number. Right? Which one's on the right? 4 is on the right. X is on the left. Right? So clearly it should be 1 minus x. And for the problem on the test is 4 minus x. Okay? So that is the radius. Okay, clear. All right. So now the area is 2 pi r ds. So step 1, you put what is r? I is 1 minus x. Not x minus 1, right? And this is a dx dt squared plus dy dt squared. And here t is from 0 to pi over 2. Okay. Then the next step, you replace x by sine t, and here there is a derivative of x is cosine t squared, and 2 cosine 2t squared dt. Okay. Yeah. Right. So here's the next problem. It's problem number 6D, and x equals t squared minus t cubed. Right. Y equals t plus t to the fourth power. T is between 0 and 1. Right. So the rotation here is about x-axis. All right. So set up an integral for the area of the surface. Okay. So please do it, and then let me know what we got. Right. So step 1, we should do try to sketch the graph if possible. Okay. That's what we did in the last section, right? So I'll probably just draw a couple points. Okay. Maybe not necessary. Let's see, this is a Q, right? So X is going to be t squared 1 minus t, right? Y equals t 1 plus t cubed. So I think y is always positive, it's clear. And this is also always positive for t between 0 and 1. But when t equals 0, both are 0. So this is origin. When t equals 1, x is going to be 0, y is not going to be 0, y is going to be 2. Right? So it's 2. So x is positive, y is positive. It's in the first quadrant. So the graph will look like the curve looks like that. Right? Yes, right? Then it's rotated about the x-axis. Okay. How can I solve the problem? You have to take arbitrary point. Okay, this is an arbitrary point with coordinates and y. And what is radius? This is the radius. The radius is going to be y value of the coordinate. And the y is going to be t plus t to the fourth power. Okay, that's it. And the ds is going to be dx of dt squared plus dy and dt squared and dt. And you can differentiate, right? The derivative of this will be 2t minus 3t squared and squared plus 1 plus 4t cubed and square dt. So you get everything. Then the formula area is going to be integral 2 pi r ds, right? And that's stuff from 0 to 1, 2 pi. What is r? R is a t plus t to the fourth power. What is ds? We already get that. Do you need to simplify it? Probably not. I just needed to know the formula. Okay. That's what I want to say. Okay. All right, let's take a look at the next one. Maybe we can find exactly. I probably cannot evaluate this integral. Okay, it's too complex. The second one is x equals 3t squared, y equals 2t cubed. T is between between 0 and, make it simple, this one. Okay, so the rotation is about the y-axis. Okay, find the area of the surface. Okay, so what is the surface? Sketch it, right? So let's sketch the graph. And again, when between 1 and 0 and 1, both x and y are positive, so the curve is in the first quadrant. And when t equals 0, it's here. When t equals 1, then I got 3 and 2, that point. So here's the curve, okay? Oops. So this is the curve, and it's located about the y-axis. Okay. So first step, you take a point on the curve. and draw the radius. So you mark it clearly, radius is equal to x. Okay, in our particular case, x is going to be 3t squared. Right. So the area is going to be 2 pi r ds. I is x, ds is dx of t square. Right. Then you can choose from 0 to 1, then you can, for details here, x is going to be 3t squared. Right, that's x. That's the radius x, right? And then here, 3t squared. Now we have to differentiate. So it's a 6t. Okay. And then the derivative y with respect to t is also 6t, but 6t squared and squared. So actually you can take the 6 out, right? So you have 6 out, so 36 pi from 0 to 1 t squared, and then have a 1t squared out to t cubed, which is 1 plus t squared dt. All right, so question is, what is the best way to solve the problem? Integrate. Think about it. All right, so you can use a trigonometric substitution because you see 1 plus t squared there. But I'm trying to use a regular substitution. Let it to be 1 plus t squared, du equals 2t dt. That's okay. So this is going to be 36 pi from 0 to 1. And t cubed is going to be t squared, right? Right? So this is t dt. Okay. So t squared is going to u minus 1. That's just a u, 1 plus t squared. And the t half of the u. And u is from t is equal to 0, t equals to 1. So it's from 1 to 2. That is the domain for me. Okay. All right, so then I think we can evaluate this integral. 36 divided by 2 is going to be 18. And that's u times u to the 1/2. So you get, yeah, if we express this way, the sum of the two power functions, then you can find the antiderivative quickly. Okay, that'll be 2 over 5 u to the 5 over 2. That'll be 2 over 3 u to the 3 over 2. Okay. Finally, we put the numbers there. Okay, that's the first part. Second part, just plug one for you. Then you can simplify it when you get an answer, if you have time. Right. Let's take a look at the next one. So this is not complicated. T equals t squared, y equals t cubed. Okay. So it looks like that. And the notation is about horizontal line, y equals 1. Oops. All right, we're going to rotate this curve. Set up an integral for the surface of the revolution. So the area of the surface. Okay. So here t is between 0 and 1. So the original curve is this piece. Okay, please work on it. I just want to give me the formula. This is the integral with respect to t. Okay. Of course, you can try and set up an integral with respect to x or respect to y. But I just here wanted to express the integral with respect to t. Step 1, remember, choose a point on the curve, draw the radius, express the radius in terms of x or y, then you can express it in terms of t. Then the integral will be 2 pi r ds. Okay, so please do it. All right, so choose a point. So this is a point, x and y. So where's the radius? This is radius. All right. So let me write down the radius. Radius is going to be the difference, 1 minus y. Right? So our original form is 2 pi r ds. Then you can put, use the x, y variable, right? So that's 1 minus y and square of dx dt squared dy dt squared dt. So that is from 0 to 1. Right? Then you replace y by t cubed. And the derivative x with respect to t is 2t. That'll be 3t squared and squared. Right? You got it? I hope you understand how to set up the integral for the surface of the radius. Right. Don't memorize the specific formula for the function f. Right? Using function f for the surface, for the area surface of revolution. If you then you probably cannot figure out the radius, because actually you have to tell me what is the radius, right? Right. If you look at the test you submitted last problem, some of you may be confused because I asked you several questions. Set of integral with respect to x variable, set of integral with respect to y variable. And the rotations about x-axis, rotations about y-axis, or by a vertical line. But if you can draw the picture, you pick up a point on the curve with coordinate x and y, and then draw the radius, then you can tell what is the radius right away. Right, so this is are we able to evaluate the integral? Maybe, maybe not. Okay. Okay. Here we just want to set the integral, so we don't need to spend time to evaluate. Okay, this is a problem without using the parametric questions. Find the exact area of the surface. This is generated by the curve, by rotating the curve. Y equals the quot of x squared minus 1/2 natural x. X is between 1 and 2. This is about the y-axis. Right. So this time the equation is given by function. Okay. Step 1, you have to draw the graph. Okay. When x equals 1, and somewhere here, okay, when x equals 2, so the rotation is about y-axis. So when you draw it, it looks like that. So now what is next step? Remember, take a point on the curve. Take a point on the curve and draw the radius. That's all I need. Right? And then express the radius in terms of x, y. So it's x. All right. Then you have to decide which variable you're going to use. I'm going to use x. So ds is going to be 1 plus dy over dx squared. then I'm done, right? So the area is going to be integral 2 pi r ds. So this time I use x variable from 1 to 2 pi. What is r? R is x, so that's good enough. So that's 1 plus. Then you differentiate y with respect to x. It's half of x minus half of 1 of x squared dx. Okay. I can tell that this immediately will be 1/2 of x plus half of 1 of x squared. Minus becomes plus. And then you can get rid of the radical. Okay. Then you simplify it, multiply this out. I get, I think 1/2 is gone, 2 is gone. So you get x squared plus 1. Okay, then the antiderivative 1/3 x cubed plus x evaluated to end point. Right. So you plug them into the formula. Right, then you get answer. Okay, I think I haven't done enough problems. I'm going to stop here. I continue grading the test.